last time we met, we were discussing about the mode, and we said that the mode is the value of x in the range the values of x in which the PDF is defined, whose f of x is greatest. Example, if this is our f of x, where f of x is equal to kx into 3 minus x, when x is defined from 0 up to 3, it is 0 elsewhere. Question 1, I will find k. What the value of k? And then Roman 2, maybe find the mode. So we discussed this question, but we need to review what transpired. So to get the value of k, we say you integrate the negative method, positive thinking, but integrate the PDF and equate to 1. So when you equate the PDF, when you equate this integral to 1, you're able to find the value of k. Now to get the mode, like we have said, the mode is the value of x in the range of the values of x in which the PDF is defined, whose f of x is greatest. For example, our mode must be between either 0 or 3 or between 0 and 3. But that value must be giving us the maximum value of f of x, that when we substitute it here, we get the maximum value of that f of x. Now we said if the PDF is nonlinear and simple to mean if it has only one interval, the very first step is to find f prime of x. Now after getting your value of k, Roman 1, you definitely redefine f of x, which is kx into 3 minus x. This time, our k is going to be a known value. This is when x lies between 0 and 3. So you got this f of x whose k is already known. You differentiate it once. When you differentiate that once, get f prime of x. We are now finding the mode. This is for the mode. You differentiate the original function once and you equate the first derivative to 0. After equating the first derivative to 0, you definitely get the values of x. Now after getting values of x from step 1, you differentiate again to get f double prime of x. When you get f double prime of x, that is now when you get this one, you differentiate this one. To get this, you differentiate that. Now after differentiating this, you get f double prime of x. We get the values of x from step 1 and substitute them in f double prime of x. The value of x whose f double prime of x is going to be less than 0, in brackets, it is going to be negative, is going to be our mode. So we shall say that the mode is equal to that x value. You expect the value of x that gives you f double prime of x when it is less than 0, and you conclude with that as the mode. If you can't realize that it is less than 0, then you test the values of x, and that x value that gives consider that one which is inside this range, and it is the one that will test in this one. So you have to confirm that indeed the values of x that you are testing, they are all inside the range. And once they are inside the range, obviously one of them must give the second derivative when it is less than 0 or when it is negative. And that which gives the second derivative when it is less than 0 will definitely be the mod. Now we can as well be asked to find the mod of a linear PDF. And to get the mod of a linear PDF, the steps are going to vary a bit, because for a linear PDF, if you differentiate the first time, x phases out, and you are unable to equate the first derivative to 0 to get the x values, because you have constants on both the sides. So if you are given, for instance, if you are given f of x as 1 over 8x, that is when x lies between 0 and 4, and it is 0. Else where, supposing the question is saying that random variable x as the PDF f of x given by this one, and the required is to get the mod. We cannot employ these steps, because when you employ them, you will be unable to get that x value to inspect. We said the first step is get f of x my f of x is 1 over 8x. This is when x lies between 0 and 4. Now, if you attempt to follow these ones, it will not give you, because now when f of x is 1 over 8x, linear PDF. So if we sketch, we say in the sketch you create an impression that you are drawing the PDF on scale. So in our graph, this is now